Query from your side up to this? Anything that I should repeat? Anyone? Supratik, any query? Mohana? Amar Kumar? Paditro? Any query? বাহ, কি সুন্দর ক্লাস হচ্ছে। হ্যাঁ, ওদিকে গান চলছে, এদিকে ক্লাস হচ্ছে। বাহ, ভেরি গুড। अच्छा गाना था। So this is a Bhojpuri song, na? Actually, I am from Asansol, so I have also heard lots of Bhojpuri songs. Debojyoti, any query? So it seems either everything is going above your head, so bouncer, or you know everything. Which one? Okay, let uh, ask some question to you. Anyone can answer. So this stack data structure I have discussed for our this recursive function, stack data structure. Now, any other example where we need this stack data structure? Anyone? Any other example where we need this stack data structure? Give one example. Am I audible? Am I audible? Unmute, no? I have unmuted you all, no? All participants are unmuted.
Yes, sir, you are audible.
Then
Yes,
give
sir.
me the answer. Except, so I have given one example, recursion, where we need stack data structure. Now give me another example where we need this stack data structure. Any other example? Nothing coming in your head? Any other example where we need stack data structure? See, I have already written here, na? What is this? Reverse. If you want to make anything in reverse order, suppose I have a character set A, B, C, I want to make it reverse. What I will do, I will put it into stack. So A, B, C, then I will, so I put it and then get it out. So it will come out in this form. So it become reverse.
Sir, Please explain the pseudocode once more.
Okay. So pseudocode means it is combination of something from the algorithm and something from the program. See how you will write a program. So you will write a program like this. Na? Suppose this prime number. So the prime number checking will be like this: for I equal to 1, I less than equal to n, I plus plus. Okay. Then what I will check? I will check whether this number is divisible by this numbers or not. Okay. Then what I will do? I will increase my counter. My counter is initially in 0. Okay. After coming out from the loop, I will check if count equal to 2, printf prime, else not prime. Very clear? So this is your program. You are following some syntax. This is a C language program. You can write it in Java also or Python also. So you have to follow the syntax of that language. That is called a program. Very clear? But what is algorithm? If I want to write this in algorithm form, it should be like this. Divide the given number with 1 to n and check whether it is divisible or not. If it is divisible only twice, then prime. Are you getting? So this is algorithm. I'm writing in my own language, step by step. But what is pseudocode? Intermediate these two. So one simple example of pseudocode is this one. I'm not writing a syntax for a particular for loop, but I'm writing it in this way. Loop I starting from 1 to n. Then you are writing if n modular division I equal to 0, then set counter equal to counter plus 1. So this is one pseudocode. Logic clear? This is one pseudocode. This is one program, and this one is one algorithm. So pseudocode is intermediate. It is not following particular syntax, but it is giving almost like a program like structure. So it means first you have to write the algorithm, then you have to go for the pseudocode, then you have to go for program. This must be your sequence of programming writing. First, the algorithm, how to solve the problem. Then you will write some pseudocode. Means here I have written it like this. Na? I have written divide the given number with 1 to n and check whether it is divisible or not. So you have converted this thing into this loop I 1 to n if n modular division I equal to 0. So this is pseudocode. And finally, when you are following some particular syntax of a programming language, then it is called a program. Okay? I hope you know what is software. So program is set of instructions and software is set of programs. Okay, now coming to the problem. So this is the first solution of prime number. Okay, so this is the first solution. N I plus plus, then inside this if n modular division I equal to 0. So I hope you know this. Modular division is known. I am not discussing about it. So if it is divisible, then it will give you 0. So that's why I'm checking it, and I'm modifying the counter plus plus. Then I'm checking if counter equal to 2. Then I will printf prime. Okay, and it is not prime. So this is a simple solution or simple code of this solution. Any query for this solution? No. I think this is very simple solution. Now, what is the another solution? Now, solution number 2. So here, the solution is I am checking from 1 to n if the given number is divisible only twice. If the given number is only divisible twice, then it is a prime number. So from okay. So this is solution 1. In solution 1, I am checking the given number by all the numbers starting from 1 to n. Now, what is another solution? Solution number 2. Instead of checking 1 to n, I am checking
Sir, your screen is not visible.
so this is solution number 2. So in solution number 1, we are checking the number is divisible by 1 and n. It means the number is not divisible by 2 to n minus 1. Am I clear? What is the definition of prime number? That the number is only divisible by 1 and itself. It means it automatically defines that it is not divisible by 2 to n minus 1. So I am applying this logic here. So the reverse logic. So how to write it? For I equal to 2, I less than n, I plus plus, if n modular division I equal to 0 means divisible, then I'll break the loop because it is divisible. So if it is not divisible, then it is called prime. So after coming out from the loop, I will check if I is equal to n, then printf prime, else printf not. Okay, clear this logic also? So the first logic is a number only divisible by 1 and n, it is prime. It means the number is not divisible by 2 from 2 to n minus 1. So I'm checking the same logic here. If it is divisible by any intermediate number, then I will break and I will check what is the last value of I. If in this way, when this loop will execute, means stop, if this one is not satisfying, then this loop will stop when I becomes n. So I become ends means I becomes n means this number is not divisible by 2 to n minus 1. That's why I becomes n. So I'm checking the same thing outside the loop. If I equal to n, this prime, otherwise. Okay. Now there is another solution. What is the next solution? Next solution is if a number is not divisible by 5, then definitely it is not divisible by 10. Are you getting? If a number is not divisible by 2, then it is definitely not divisible by 4. So if I already checked that the number is not divisible by 2, then no need to go for checking with 4. It means we are only checking from n by 2. Logic clear? So this for loop becomes like this: for I equal to 2, I less than n by 2, I plus plus, if n modular division I equal to 0, then break if I equal to n by 2, printf prime, else printf not prime. So this is solution number 3, third solution. Now there is another solution, solution number 4. I don't know whether you know this or not. What is the logic? The logic is if a number is not divisible by 2, then it is not divisible by 4, which is same like this. If a number is not divisible by 3, then definitely not divisible by 9. If a number is not divisible by 4, then definitely not by 16. If a number is not divisible by 5, then definitely not 25. It means, what is the meaning of this? Square. Okay, this is the meaning of square. So instead of go up to n by 2, we will, in this case, we will move up to square root of n. I will give you one example. So the other parts are same. Equal to 0, break. Okay, if I is equal to sqrt n plus 1, printf prime, else printf not. So one solution, sorry, one problem, whether a given number is prime or not, it has 4 solutions. I have written 4 different solutions. Now I will go for checking which one is better with respect to time. Because I have already told time complexity, time management is the most important thing. Because we have enough space nowadays. 4 GB RAM is enough space, but time is still same. So you have to check whether it is taking much longer time or shorter time. Now, how to measure the time? See, in case of any program, the time is measured on the basis of statements. On the basis of statements. So, one statement, suppose one statement required C time. So C may be second, millisecond, whatever, microsecond. So suppose one statement execution need C time, then number of times will give you the, number of statements will give you the total time. Means this into C will give you total time required to execute a program. Okay. Now, what is statement? In case of C language, how statement is represented? By semicolon. Okay. So one semicolon means one statement. So in this program, how many statements? So this is 1, 2, 3, 4. Then if satisfy 5, then 6. In this way, this will execute. Then if suppose the given number n equal to is say 30, say 37. Okay. So see how many statements will be executed to check whether n equal to 37 is prime or not. So in this case, how many statements will be executed? Now see how many statements will be executed. It depends on n, because n is a variable. It is not a fixed value. So it means if I roughly draw the picture, it will take n equal to 37 minimum statements, because 37 times I have to execute this loop. Logic clear? Because I am checking from 1 to 37. So this will take 37 minimum. Now come to this one. Come to this one. So if n equal to 37, how many times you are comparing? You are starting from 2 to less than n. It means t, you can say 35, because I am removing 1 and n. I am removing. So it will take 35. Now coming to this problem. It is starting from 2 up to n minus 2. So if n is 37, so it will go up to 18. Integer division, so 18. So from 2 to 18. So how much? 2 to 18 means? 2 to 18 means 17. See, from 35, number of statements have reduced to 17. Now come to this one. Come to this one. Now n is 37. So what is square root of n? Obviously, it should give you the integer value. So it is 6. So how many comparisons you have performed here? From 2 to 6. Means only 5 comparisons. So how much time it will take? 5 statements it will need to execute. So first one, 37 statements. Second one, 35 statements. Third one, 17 statements. Fourth one, 5 statements. So with respect to time, this one is the best solution. So whenever you are writing an algorithm, see in our practical problem, there are different solutions to reach from Kolkata to Delhi. If my goal is to take the minimum time one, then I will prefer flight. If I want minimum cost one, I will go for cycle. So we always, in case of programming language, we always try to check which one is taking minimum time. Okay, now see, suppose in a condition, you are writing the condition like this. Suppose this condition I am writing in this form. Suppose I am writing it is equal to n minus 1. This is same, na? Less than n is always equal to n minus 1. Now, can you tell me which one will execute first? I'm unmuting you. Which one will execute first? Which one will execute first? If I write I less than n or I less than n minus 1, which one is faster? Anyone? I less than n or I less than equal to n minus 1. Which one will execute first? And execute faster,
N
not
minus 1.
fast.
Second one,
minus
n
one.
minus 1.
Why?
N
Second
minus
one.
1.
Why? Why?
Because it has less steps.
Absolutely wrong. See, here there are two operators. One is this relational, one is this. So if you write it in this form, first compiler will execute this, then execute this. It will take more time than this one. This one is best. So whenever you are writing any condition, don't use any into plus this type of terms. Better you suppose there is a variable. Suppose you have to write it like this: j less than n minus I. You want to write it like this. Then better write it p equal to n minus I. Then write here only p. It will execute faster. Why? You got the logic now? Why this one will take more time? Because first it will execute this, then it will compare. But there is only this part. Logic clear? So both time I will reach n. Here also I will reach n. Here also I will reach n and then stop. Then stop. So number of I, so means number of iteration is same for both the equation. Are you getting my point? When this will stop, it will stop when I becomes n. Similarly, when this will stop, when I becomes n. So in both the cases, the number of iteration is n. But why this one will take more time? Because every time, whenever it is getting some value of n, it will perform the -1 value, then it will compare. See, this will be executed every time. Na? Whenever you will come back to here and then you have to go via this. So every time you have to check the condition. So if you write in your condition part any equation like this, it will make the code slower. Similarly, in case of array, instead of writing this, if you write it in this form, this will execute or run faster than this because compiler has to convert it into this. Remember these things. These things are very important. So in this problem, whether a given number is prime, I have shown you 4 different techniques and I have shown you which one is better. Okay, this one is better because it will take less number of iteration, less number of statements. That's why we will go for this algorithm. So whenever you are writing any algorithm, you have to take care that whether my algorithm is best or better with respect to time complexity or not. Yes, there is space complexity issue also, but that is very negligible because nowadays space is huge. But yes, in some problems we also take care of, suppose we are performing any image processing problem. Nowadays convolutional neural network, image processing problem. In those cases, we must have to take care of space complexity also. Because image is a huge thing. Image is not a simple thing. There are pixels having value from 0 to 255. If it is a color, then 3 plane. So in those cases, we have to take care space complexities. And there are every year different competition are organized to check whether algorithm is faster or not. There are different competitions organized for very well-known problems. Can you make it more faster? So these are the tricks you have to take care. Means whenever you will go for campusing like this Code Vita or Infosys TechQ. So in this app, means online portals, you have to submit your codes. They will check your code whether it is running within a time interval or not. They have set some time. If your code is not executing within this time limit, then it will be rejected. So you have to take care of all these things. How to make your code. Obviously, there is one, a notion that there is always a trade-off between space and time. It means whenever you want to reduce the time, automatically space may increase. See, here we are using square root function. Na? So it will call a function. So that function will be copied. So your code will be increased. So space is increased, but time is reduced. See, whenever you are seeing this practical problem, there is always a trade-off
Sir,
between